Imagine you own a small independent toy store.
Okay, I'm picturing it. Lots of Lego sets.
Right. Tons of Legos.
Mm.
And over the last, like, 5 years or so, you've built up this just massive list of customer data.
Which is incredibly valuable if you use it right.
Exactly. You have names, addresses, purchase histories. You even have the ages of the kids you're selling to.
That's a lot of data points.
It is. And on top of all that, you have another massive list sitting around, which is your actual physical inventory.
Right, the stuff sitting on the shelves.
Yeah. So right now, let's say it's a Tuesday morning, and you need to figure out instantly which toys are just, sitting there bleeding capital through holding costs.
The dust collectors.
The dust collectors, exactly. And you also need to know which specific age demographic you need to target with an email campaign this afternoon to hit your quarterly profit goals.
That is a very high stakes Tuesday morning.
Right. And you could spend hours, or realistically days, trying to cross-reference all of that manually, basically just guessing at the trends.
Which a lot of small business owners actually do, unfortunately.
They do. Or you could let the data speak for itself in a matter of, like, seconds.
And that right there, that is the defining difference between running a business proactively versus just, reacting to whatever happens to you.
Exactly. So welcome to this deep dive for Managing the Future, the MIS podcast. We are putting this together specifically for you, the students at the Dr. Sampak College of Business at Tarleton State University.
Go Texans.
Yeah, absolutely. And, this is also for any working professional out there who needs to basically stop guessing and start knowing.
It's universally applicable stuff.
It really is. So today, we're using that toy store scenario to tackle Module 23, which is the review of Excel fundamentals.
A very necessary review for a lot of people, I think.
Oh, for sure. And we're pulling our framework today directly from the textbook Connect Master, Management Information Systems. That's by Richard Tedmont and Casey Wilhelm, specifically the 2026 release from McGraw-Hill.
It's an essential module, really. But before we get into the weeds of analyzing local inventory and, customer data for our toy store, I think we need to maybe contextualize this a bit. Contextualize how? Well, because in our last discussion, we were looking at data management on a completely different, almost, philosophical scale.
Oh, right. You mean Module 22.
Yeah, exactly.
The one covering blockchains and cryptocurrencies.
Right. So in that module, we were looking at the absolute ultimate distributed data ledgers.
Right, the macro level stuff.
Exactly. We defined a blockchain as this immutable, decentralized public ledger. It's a database architecture that's built on these blocks where each block contains a cryptographic hash, a timestamp, and then the actual data from the block that preceded it.
And that chain of custody is what makes the historical record basically impossible to alter, right?
Precisely. It's practically permanent.
And the key takeaway there was how they maintain trust without needing a centralized authority, like without a central bank.
Right, because they rely on those consensus mechanisms we talked about.
Yeah, like proof of work, which, demands that massive computing power to validate transactions.
Right, the energy-intensive one.
And then proof of stake, which relies on users putting up collateral and proof of authority for those private enterprise-level chains.
You've got it. That underlying, basically trustless technology is what enables everything from those highly volatile cryptocurrencies.
Like Bitcoin and Ethereum?
Yeah, all the way to smart contract platforms and even stablecoins that, peg their value to fiat currencies. It's the entire infrastructural foundation for decentralized finance.
Right. So the big question is, why the pivot today? From macro to micro.
That's the perfect way to phrase it.
Here is the thematic bridge I really want to walk over for you guys listening. Blockchains represent this fascinating future of decentralized, immutable, macro-level ledgers.
Which is great for the global economy.
Right. But the day-to-day reality of actually running a business like our local toy store that requires absolute mastery over local data ledgers.
You need a ledger that you can actually mess around with.
Yes. You need to manipulate it, build models, project future earnings. And the universal tool for capturing, cleaning, and analyzing that local data is Microsoft Excel.
That is such a critical distinction to make because blockchain is the tool for when you need absolute trust and permanence across a massive decentralized network.
You don't want anyone changing those numbers.
Right. But Excel is the tool for when you need flexibility. You need to understand, manipulate, and act on your own proprietary data.
Right now.
Yeah, right now, in your own office, so you can make a strategic decision before the end of the day.
Okay, so before we jump into exactly how to build those strategic models,
Yeah.
I just want to quickly remind you, the listener, to take a second to like, subscribe, follow, share, and, comment on whatever platform you're using to listen to this deep dive.
It really helps out.
It does. And we just want to make sure you never miss a module and that you can join the ongoing conversation with your fellow business majors.
Absolutely. So let's establish Excel's actual utility in the modern corporate environment, because there is this lingering misconception, particularly among newer students, I've
That was
noticed,
a misconception.
that Excel is just this niche tool for information systems specialists, or I don't know, maybe just for accountants doing tax returns in a back room.
Oh, man, we should not be further from the truth.
It's completely wrong.
If you are going to be a professional in basically anything, marketing, supply chain management, human resources, or executive leadership, Excel is essentially the universal language of modern business.
It really is.
If you don't speak it, you literally can't participate in the conversation. You'll just be sitting in a meeting nodding along while someone else drives the strategy.
And Tedman and Wilhelm make this very clear in the text. And because it's the universal language, getting started is actually designed to be highly accessible.
Which is nice. It's not gate-kept.
Exactly. You can operate through the heavy-duty desktop application, or if you're on the go, through the cloud-based Microsoft 365 environment.
Which runs in any browser, right?
Right. They even point out that Microsoft offers a free Excel viewer program. So even if a machine isn't fully licensed, you can still open, read, and print these critical files without paying for a subscription.
But let me push back on the whole universal aspect for just a second, because the reality of the modern office is actually really fragmented right now.
Okay, fair point. How so?
Well, you've got startups running almost entirely on Google Workspace, right? Then you have creative agencies using Apple hardware. And then you have these massive enterprise clients still on legacy Microsoft systems.
That is a very common ecosystem these days, yeah.
So if I'm managing this toy store, I might have a supplier sending me a Google Sheet. And maybe my accountant is using Apple's iCloud numbers. How does Excel remain the standard if everyone is typing in different platforms?
It remains the standard because all of those competing platforms are basically forced to build bridges back to Excel.
Oh, I see.
Yeah, the authors cover this cross-platform reality specifically because it is the day-to-day friction of business. If that supplier sends you a Google Sheets file containing all their new wholesale pricing, you don't actually analyze it in Google Sheets if you want maximum processing power.
You pull it out of Google.
Exactly. You go to the File tab in Google Docs, you select Download, and you explicitly choose the Microsoft Excel .-XL-SX format.
And what if the accountant sends a financial summary using Apple's iCloud numbers? Because I know Macs can be tricky with Microsoft stuff sometimes.
It's a slightly different interface, but it's the exact same concept. You open the file in iCloud, click the View Numbers, Tools icon. It's that little circle with 3 dots, then select Download a copy, and you just choose Excel.
So it all funnels back.
Right. The entire industry, regardless of what software they prefer to physically type in, eventually exports to the .XL-SX standard to do the heavy lifting.
Okay, so we've imported the data, we've hit Save As, or, Control S, to secure our local copy.
Always be saving.
Always. So now we're staring at the grid. And for a business student who maybe hasn't spent much time in data architecture, that grid can feel a little abstract.
It's just an endless sea of little white boxes.
Right. We all know what rows and columns are mechanically, but how should we be thinking about them conceptually in a business context?
Okay, think of the grid not as a static table drawn on a piece of paper, but as a massive, interactive referential architecture.
That sounds intense.
It's simpler than it sounds. So the columns, those are the vertical lines identified by letters. They usually represent your variables or your categories.
So for the toy store, column A might be customer last name.
Exactly. Column B is product category, column C is purchase price, and so on.
And if you click the letter itself at the very top, you grab that entire category of data all at once, right?
Correct. Now the rows, those are the horizontal lines identified by numbers running down the left side. They typically represent individual records or observations.
Okay, so row 2 is the specific transaction for the Smith family buying a board game.
Yes. And row 3 is the Jones family buying a bicycle.
Which means the actual intersection of that column and row is the specific data point.
Right. It's the basic unit of the whole spreadsheet.
Okay, I like to unpack this with an analogy for people. A spreadsheet is basically just a massive game of Battleship.
Oh, that's perfect. Yes.
If we are looking at column B, row 3, The cell address is B3, hit or miss.
Exactly like Battleship. But it's more than just a box holding a word, right? It's a variable in a potential equation.
Right, so when you click on a cell, it becomes the active cell, ready to receive whatever input you have.
And you can always verify exactly where you are, your Battleship coordinate, by checking the name box, which sits just to the left of the formula bar.
But you're hitting on the most crucial concept here, how Excel actually interprets the data you put into that cell, because it's not all the same to the software.
No, it's not. The text makes a very sharp distinction between labels and values. And honestly, I've seen professionals completely wreck financial models because they didn't understand how Excel parses different data types.
It really is fundamental to how the software, quote-unquote, thinks.
Exactly. So a label is text. Its entire purpose is just to help the human user understand what they are looking at.
Like a header?
Right. Q3 revenue, or employee ID, labels do not interact with other cells mathematically. Excel knows this, so by default, when you type a label, it aligns that text to the left side of the cell.
It pushes it to the left. But a value is something Excel recognizes as actionable.
Like numbers, dates, formulas.
Right. When you type a value, Excel immediately assumes you might want to do math with it at some point, so it automatically aligns it to the right side of the cell.
Now, here is where the business application gets a little tricky and where a lot of systemic errors originate. What happens when you have numeric data that you never, ever want to be treated mathematically?
Ooh, a zip code is the classic example here.
Perfect example.
If I have a column of zip codes for my toy store customers, I don't ever want to accidentally multiply a zip code by, like, a local tax rate.
That would be a disaster.
Furthermore, if I have a customer in New England where the zip code actually starts with a 0, like 02116, if Excel treats that as a math problem, it will just drop the leading 0.
Because mathematically, 02116 is just 21116. The 0 has no mathematical value.
Right, which completely ruins your geographic marketing data if you try to map it later. So you have to force Excel to change its default behavior.
You have to trick it.
Yeah, and you do this by typing an apostrophe right before the number. If you type apostrophe 02116, that apostrophe acts as this hidden command telling Excel, hey, treat this strictly as a categorical label.
And the apostrophe disappears in the visual display.
Exactly, it vanishes from the grid, but the data stays safely aligned to the left. That leading 0 is preserved, and it is totally quarantined from any of your calculations.
It's such a tiny formatting trick, but it literally saves hours of auditing later.
Okay, I want to shift gears slightly to navigation, because the textbook spends some time detailing the mouse pointer.
Which can feel a little basic at first glance.
It initially felt super basic to me, like I know how to use a mouse. But when you realize that the pointer actually changes shape to execute entirely different macro commands, it becomes a lot more important to pay attention to.
The pointer is essentially your primary interface for data manipulation. So the standard thick white cross, that is your selection tool.
And that's the default state.
Right. It's how you highlight a single cell or click and drag across a whole range of cells.
And then the insertion tool is just the text cursor. It looks like a capital I.
Or an I-beam, yeah.
Yeah, an I-beam. It tells you that you are actively typing inside a cell or up in the formula bar.
Right. Then you have the expansion tool, which appears when you hover exactly on the border between two column letters or two row numbers.
It looks like a line with little arrows pointing outward.
Exactly. You use that to physically click and drag the width or height of the grid to fit your data.
But the one we really, really need to focus on is the fill handle. Because I think if you understand the fill handle, you transition from using Excel as just a digital piece of paper to using it as a massive automation engine.
The fill handle is critical for efficiency. It's a game changer. So when you select an active cell, you'll notice this very small, solid square in the bottom right corner of the selection box.
It's tiny, you have to look for it.
It is. If you carefully hover your pointer over just that little square, the thick white cross transforms into a thin, solid black cross.
And if you click and drag that thin cross down a column of, say, 1,000 rows,
it autofills the adjacent cells, it can perform a direct copy of the data, or brilliantly, it can extrapolate patterns.
Like what kind of patterns?
Well, if you type Monday in one cell and drag the fill handle down, Excel is smart enough to populate Tuesday, Wednesday, Thursday automatically.
That's so cool.
It is. But its true power, which we will get to shortly, is rapidly replicating complex mathematical formulas across massive data sets without having to retype them.
Which sounds incredibly efficient, assuming the data you are working with is pristine.
That is a massive assumption.
Right. Let's bring this back to reality for a second. Let's go back to our toy store. If I am importing a customer list from some old legacy point-of-sale system, or maybe I'm downloading an inventory manifest from a supplier's clunky web portal, that data is never pristine.
Never.
It is usually an absolute disaster.
And this is a reality that honestly trips up a lot of recent graduates. They expect clean data. Because in school, the data sets are usually scrubbed for you.
Right, the professor gives you a clean file.
Exactly. But in the real world, imported data is fraught with formatting inconsistencies. You'll find leading spaces, trailing spaces, completely random duplicate entries.
It's a mess.
And if you try to run an analysis or build a pivot table on dirty data, your output will be fundamentally flawed. You will literally make bad financial decisions based on bad reporting.
Garbage in, garbage out.
Exactly. Data cleaning is the unglamorous but totally mandatory prerequisite to data analysis.
Okay, so how do we actually operationalize that cleaning process? Let's say our toy store imported a list of 1,000 customer names. And because of how the old database exported it, some names have 5 spaces before the first letter, some have double spaces between the first and last name. It's just all over the place.
Well, you obviously cannot go in and hit the backspace key on 1,000 individual cells.
You'd be there all week.
The business solution is the trim function. It's incredibly elegant. You would just create a new empty column right next to the messy data. In the first empty cell, you type the formula, equals TRIM, open parenthesis, then click the cell with the messy text and close the parenthesis.
Okay, so if the messy name is sitting in cell A2, I just type equals trim parenthesis A2.
Exactly. Excel instantly processes that entire text string. It strips out all leading spaces, strips out all trailing spaces, and reduces any weird multiple spaces between words down to a single normal space.
That is so satisfying.
It is. And then you grab that fill handle we just discussed, double-click it or drag it down the column, and you have standardized 1,000 customer records in roughly 3 seconds.
Wow. Okay, so that handles the textual formatting. But what about structural errors?
What do you mean?
Like, what if a warehouse employee accidentally scanned a pallet of Lego sets twice, and now our inventory sheet has duplicate rows? That's going to artificially inflate our asset valuation.
Oh, absolutely. Well, Excel has a dedicated built-in feature specifically for data integrity like that. You just highlight your entire data set, navigate to the Data tab on the main ribbon, and click Remove Duplicates.
Just a button click.
Basically, a dialog box appears asking which specific columns should be evaluated to determine what a true duplicate actually is.
Because maybe 2 people have the same last name, but they aren't duplicates if their addresses are different.
Precisely. You set the rules. Once you confirm, Excel scans the entire matrix and automatically deletes the redundant rows, leaving your primary data intact and accurate.
Awesome. I've also run into encoding issues, which are super frustrating.
Oh, like when special characters break.
Yeah. Like you import a CSV file, and every time there was supposed to be a trademark symbol or an ampersand, the system panicked and dropped in a string of weird characters, like an @ symbol and a hashtag.
That is a classic character encoding mismatch. It happens all the time during import.
How do you fix that without hunting through thousands of rows?
To fix it globally, you use the Find and Replace tool. First, use the keyboard shortcut Control-A to select your entire worksheet. On the Home tab under the Editing group, you select Find and Select, then Replace.
Okay, so it pulls up a little window.
Right. You paste the broken character string, the weird @ symbol hashtag thing, into the Find What's box.
Yeah.
Then you type the correct symbol, like the ampersand, into the Replace With box and just hit Replace All.
And it sweeps the whole sheet. It's essentially sanitizing the environment before you start performing actual surgery on the data. Now, as these data sets grow, just managing the visual real estate on your monitor becomes its own kind of challenge.
It can get very cluttered.
Yeah. Say our toy store spreadsheet contains our entire employee roster. We have their department, their email, their phone number, but we also have a column with their current salary and bonus structure.
Sensitive data.
Highly sensitive. If I need to project this spreadsheet on a screen during a manager's meeting to discuss, shift scheduling, I can't have those salaries visible to everyone in the room.
This is where the hide function is utilized for localized privacy. It's very simple. You select the entire column containing the sensitive compensation data, let's say it's column D. You right-click directly on the letter D in the header at the top and just choose Hide.
It just vanishes.
The column physically collapses out of view. The math still works perfectly in the background if you have formulas referencing it, but visually the column headers will skip straight from C to E.
That's super useful. And to bring it back when the meeting is over and I'm back at my own desk?
You just highlight the columns on either side. So you highlight C and E together, right-click, and select Unhide.
Perfect. But as you mentioned, sometimes the issue isn't privacy, it's sheer volume.
Right, losing your place in the data.
Yeah. If I have an inventory sheet with 5,000 different toys, and I scroll down to row 3,000 to look at a specific batch of action figures, all my column headers at the top of the screen have disappeared.
You scroll past them.
Right. So now I'm staring at a grid of numbers on row 3,000, and I have absolutely no idea if column F is the wholesale cost or the retail price.
To solve that cognitive load issue, you freeze your panes. By navigating to the View tab and selecting Freeze Panes, you can actually anchor specific rows or columns so they remain completely static while the rest of the sheet scrolls beneath them.
Like pinning a tweet.
Sort of, yeah.
Huh.
Typically, you freeze the top row. That way, your critical headers, product names, SESKI, wholesale cost, they are permanently locked to the top of your monitor, providing constant context no matter how deep into the data you travel.
Okay, that covers the setup and the hygiene. Let's get into the actual mechanics of modeling. You're building a spreadsheet, you're typing in some formulas, and suddenly a cell turns into a garbled mess of hashtags and exclamation marks.
Oh, the error codes.
Yes. And for a lot of people, this induces immediate panic. They think they broke the file.
Which is entirely the wrong reaction. An error value is not Excel crashing. It is actually Excel functioning perfectly.
How is an error functioning perfectly?
Because it is the software actively communicating with you. It's diagnosing a logical flaw in your instructions so you can go in and correct it. It's a feature, not a bug.
Okay, let's translate some of these diagnostics then. If I see hashtag value EU exclamation mark, what is Excel trying to tell me?
So hashtag value indicates a fundamental data type mismatch. It means the mathematical operation you have requested is logically impossible based on the data you provided.
So going back to our earlier discussion about data types, this is like if I try to subtract a label from a value. I
Exactly.
try to subtract the word bicycle from the number 50.
Precisely. Excel cannot perform algebra on text, so it throws hashtag value to tell you, hey, go check your cell references. Something is text that shouldn't be.
Makes sense. Another really critical one is hashtag div/0 exclamation mark.
Which means you are trying to divide by 0.
Yes, which violates the laws of mathematics.
It does. Now, in a business context, you rarely type a 0 into a denominator intentionally.
No one says divide by 0 on purpose.
Right. What usually happens is you build a complex formula that divides, say, total expenses by the number of units sold. If you haven't sold any units yet, meaning that reference cell is empty or it contains a 0, the formula breaks and throws that error.
So it's a warning that your model hasn't accounted for a null state yet.
Exactly. It's telling you the data isn't complete enough to run the math.
That makes perfect sense. It's a structural warning. Now, what about hashtag REF exclamation mark? Because I feel like I trigger this one constantly when I'm moving fast and trying to clean up a messy spreadsheet.
Hashtag REF. It stands for invalid cell reference, and it is almost always caused by user deletion.
User error.
Usually, yeah.
Yeah.
You build a formula in cell C1 that relies on data living over in cell B1. Later, you decide, I don't need column B anymore, so you delete the entire column.
And the formula in C1 is suddenly looking for a ghost.
Exactly.
The data it needs to compute has been completely wiped out of existence.
Right. Excel throws hashtag REF to tell you that a structural dependency has been destroyed. You pulled the rug out from under the formula.
And finally, there is the error that isn't actually an error at all. A cell completely filled with just hashtags.
Ah, yes, the wall of hashtags.
It looks so alarming when it happens.
It does, but it is purely a visual constraint. It simply means the calculated numerical value inside the cell is physically wider than the current column width.
It just can't fit.
Right. The data is safe, the math is perfectly correct. Excel just flat out refuses to truncate a number visually.
Why not just show part of it?
Because that could lead you to misread a $1 million figure as a $1,000 figure just because the last 3 zeros were cut off.
Oh, wow. That would be a catastrophic mistake.
It really would be. So to fix it, you simply use the expansion tool on the column header to widen the column, and the full number safely reveals itself.
I honestly appreciate that the software chooses to show a scary error rather than display inaccurate financial data.
It's a very smart safeguard.
Okay, let's talk about the engine driving all of this, the actual calculations.
If a student remembers absolutely nothing else from this entire module, they must remember the golden rule of Excel. The equal sign is the operational trigger.
The equal symbol.
Yes. Until you type an equal sign, Excel assumes you are just entering static text or static numbers. The exact millisecond you type equals as the very first character in a cell, you fundamentally change the nature of that cell.
You wake it up.
Basically, you are commanding Excel to act as a computational engine.
So mechanically, if I just type 100 minus 20 into a cell and hit enter, the cell just visually displays the text 120.
It thinks it's a label.
Right. But if I type equals 100 minus 20, the cell processes the math and displays 80.
Correct. The basic operators are pretty straightforward. The plus sign for addition, the minus sign for subtraction, the / for division, and the asterisk, which you get by hitting Shift-8 for multiplication.
I do want to pause on division for a second, though, because the textbook highlights a very specific function, the quotient function, that behaves entirely differently than just using the standard /. And I can definitely see how using the wrong one could completely derail an inventory forecast.
It is a subtle but absolute vital distinction in operational modeling. Let's say you have 14 large teddy bears in your warehouse.
Okay, 14 bears.
And you want to pack them into standard shipping boxes that hold exactly 5 bears each.
Right.
If you use standard division with the /, so equals 14/5, Excel will return the exact mathematical answer, 2.8.
But I can't ship 0.8 of a cardboard box.
Exactly.
I can only ship full seal boxes.
And that is exactly what the quotient function is designed for. If you type equals quotient, open parenthesis, 14,5, close parenthesis, Excel performs the division, but it intentionally discards the remainder.
It just throws the decimal away.
Right. It only returns the whole integer, so it will return 2. In logistics, supply chain, and certain manufacturing models, you only care about whole completed units. Using standard division could lead you to heavily overorder shipping supplies.
That is a great real-world distinction. Now, as we start building these formulas, we have to talk about how Excel prioritizes complex math.
Order of operations.
Right, Excel isn't just reading left to right like a book.
No, Excel strictly adheres to the standard algebraic order of operations, which is commonly remembered by the acronym PEMDAS.
Please excuse my dear Aunt Sally.
Exactly.
Parentheses, exponents, multiplication, and division evaluated left to right, and then addition and subtraction also evaluated left to right.
Exactly. And failing to respect PEMDAS is probably the single most common source of inaccurate business reporting I see from beginners.
Let's model this for the toy store to show how dangerous it can be.
Right.
Let's say I want to calculate the percentage change in sales from Q1 to Q2.
It's a standard metric every business owner needs to track.
Right. The formula conceptually is the new value minus the old value, and then that result is divided by the old value.
Correct. So let's say Q1 sales were $10,000 and Q2 sales were $15,000.
Okay, so if I just type this into Excel linearly without thinking about PEMDAS at all, equals 15,000 minus 10,000 divided by 10,000.
Watch what happens.
Excel looks at that and does the division first, because D comes before S in PEMDAS. It divides 10,000 by 10,000, which is 1. Then it subtracts 1 from 15,000. So my final result is 14,999. Which means absolutely nothing in this context.
It is mathematical garbage. You have to use parentheses to force Excel to execute your specific business logic rather than just standard math logic.
You have to fence it in.
Right. You must encapsulate the subtraction part. The correct syntax is equals, open parenthesis, 15,000 minus 10,000, close parenthesis, divided by 10,000.
Oh.
So Excel performs the operation inside the parentheses first, which yields 5,000. It then divides that by 10,000, yielding 0.5. You format that cell as a percentage, and you accurately report a 50% increase in sales.
Their parentheses literally dictate the architecture of your logic.
They do.
Now, here is where Excel gets truly dynamic. We have our perfect formula. We want to apply it to 5,000 rows of inventory using that fill handle we talked about earlier.
To automate the process.
Right. But as I drag that formula down the column, row by row, how does Excel know which cells to look at for each new row?
This introduces the concept of cell referencing. Specifically, you need to understand the difference between relative referencing and absolute referencing.
Okay.
By default, Excel operates using relative referencing.
Break that down for me. What does relative mean to Excel?
Relative referencing means the formula doesn't actually care about the specific cell address. It cares about the spatial relationship.
Spatial, like a map.
Sort of. If you're sitting in cell C2 and you write a formula that says equals A2 plus B2, Excel doesn't read that as add the absolute values sitting in A2 and B2. It reads it as take the cell that is 2 spaces to my left and add it to the cell that is 1 space to my left.
Oh, so when I drag that formula down to the next row, to cell C3, it applies that exact same spatial logic. It looks 2 spaces to the left, which is now A3, and 1 space to the left, which is now B3.
Exactly. It updates relatively as it moves.
Which is exactly what you want. Like 90% of the time when you're calculating row-by-row data, right? Like multiplying quantity by price for individual line items on an invoice.
Absolutely. But there are critical times when you do not want the reference to slide down the sheet. You want it to stay put.
Give me a scenario where relative referencing ruins the model.
Let's say you are calculating sales tax for every single item in your toy store. You list the individual prices of 5,000 toys in column A. But the local sales tax rate, say it's 8.25%, is stored in just one single cell at the very top of your spreadsheet, let's say in cell F1.
Okay, I see where this is going. If I write a formula in row 2 that multiplies the toy price in A2 by the tax rate in F1, and then I use the fill handle to drag that formula down to row 3, under relative referencing, the formula will multiply A3 by F2.
Yes.
But F2 is empty. The tax rate didn't move, but my formula did. It slid right past it.
Exactly. The reference slid away from the critical data.
Yeah.
So every calculation after row 2 is going to be 0. To fix this, you must convert the tax rate reference into an absolute reference.
How do you do that?
You are essentially telling Excel, lock on to this specific coordinate and never, ever let go, no matter where I copy or drag this formula.
I always visualize this as dropping an anchor on a specific cell.
Mechanically, you drop that anchor by using the $ symbol. In your formula, instead of simply referencing F1, you rewrite it as $F $1.
So a $ for each part.
Right. The $ before the F locks the column in place. The $ before the 1 locks the row in place. Now, as you drag the formula down 5,000 rows, the price reference A2, A3, A4 updates relatively, but the tax rate reference F $1 remains absolutely fixed.
And typing those $ manually can get super tedious if you're building complex models, so there's a really handy keyboard shortcut.
Oh, F4.
Yes, F4. Once your cursor is in the formula bar, flashing on the reference you want to lock, you just press the F4 key on your keyboard, and Excel drops those $ in for you automatically.
F4 is a massive time saver for financial modeling. You will use it constantly.
Okay, so we've established how to write our own manual equations, but Excel is also preloaded with hundreds of built-in algorithms, which they just call functions.
To utilize a function, you have to understand the required syntax. Every function follows a very strict grammatical structure. Equals function underscore name open parenthesis argument close parenthesis.
So the equal sign triggers the engine. The function name tells the engine what specific algorithm you want to run, and the argument, the part contained inside the parentheses, tells the engine what data to actually run it on.
Exactly. And the most common core functions are accessible directly from the home ribbon via the AutoSum button. It's represented by the Greek capital letter sigma.
SUM is pretty obvious. It just adds up all the values in a specified range.
Right.
Average calculates the mathematical mean of the range.
Right. Very standard.
But let's look at count for a second. If I have a spreadsheet, I can basically just look at the row numbers on the far left to see how much data I have. Why do I need a specific count function?
Because count doesn't evaluate the physical size of the grid. It evaluates the integrity of the data within the grid.
Okay, what does that mean?
The count function specifically tallies how many cells within a selected range actually contain numerical values. It intentionally ignores empty, blank cells, and it completely ignores cells containing text labels.
Ah, I see. So if I have a list of 5,000 customers who bought a toy last year and I have a column for phone number.
Right.
If I highlight that entire phone number column and run the count function, it's not going to return 5,000. It's going to return, say, 3,420, telling me exactly how many customers actually provided a valid phone number, skipping all the blanks.
Precisely. That's a metric of data completeness. It allows you to audit the quality of your data set very rapidly.
That's incredibly useful for marketing.
Yeah.
And then we have max and MIN, which are pretty self-explanatory. Max returns the highest value in a data set. MIN returns the lowest.
They seem basic, but applied strategically, they are powerful exception reporting tools.
Oh, so.
In an inventory matrix of, say, 10,000 SKUs, running a max function on your days on shelf column instantly identifies your single most stagnant, problematic product without requiring you to sort and sift through the entire massive database.
It just bubbles the worst problem right up to the top.
Exactly.
Okay, I want to move into what I consider the real meat of this module. Adding and averaging, great, but it's really just math. How do we start building automated decision-making into our spreadsheets? How do we use advanced business logic?
This is where we transition from Excel acting as just a fancy calculator to Excel acting as a true analytical engine, and it begins with the IF function.
The IF function. I feel like this is where Excel gets intimidating for some people.
It doesn't have to be. The IF function simply allows you to program conditional logic into a cell. You instruct Excel to test a specific condition. If that condition evaluates as true, Excel outputs one result. If it evaluates as false, Excel outputs a completely different result.
The textbook uses a grading scenario for a college professor, which is super relatable for the students listening. Let's walk through the syntax for that.
The syntax requires 3 distinct arguments separated by commas. It looks like this. Equals IF open parenthesis logical underscore test comma value underscore if underscore true comma value underscore if underscore false close parenthesis.
Okay, so if a professor is looking at a student's final grade, and let's say that grade is sitting in cell B2, and the passing threshold for the class is a 65.
The formula would be equals IF open parenthesis B2 is greater than 64 comma quote pass quote comma quote fail quote close parenthesis.
Let's dissect that piece by piece. The first argument is the logical test, B2 greater than 64. Excel literally looks at the number in B2 and asks, is this strictly greater than 64?
Right. The second argument dictates the true state. We put the word pass inside quotation marks to tell Excel to output that specific text string if the grade is 65 or higher.
And the quotation marks just tell Excel, hey, this is text. Just display exactly what's inside here.
Exactly. And the third argument dictates the false state. We put fail in quotation marks. You write that conditional logic once, you double-click the fill handle, and in a fraction of a second, a roster of 800 students is definitively categorized.
Now let's translate that power to our toy store scenario.
How would you use it?
I'd use it for automated supply chain alerts. Let's say I have a column for current inventory level. My logic would be equals IF. Current inventory is less than 10, comma, quote, reorder, immediately, quote, comma, quote, stock sufficient, quote.
That's a perfect application.
Right. I don't have to analyze the actual numbers anymore. I just scan the column, and the spreadsheet actively screams at me when I'm about to run out of a popular toy.
That is exactly how modern businesses manage exception reporting. You use conditional logic to highlight only the data that requires actual human intervention, saving you time.
The other advanced function the text heavily emphasizes is PMT, which moves us out of pure logic and straight into corporate finance.
The PMT function. It calculates the periodic payment for an annuity or a loan, assuming constant payments and a constant interest rate.
So debt.
Yes. Whether you are buying a delivery van for the toy store or analyzing a multi-million-dollar commercial real estate loan, this function is foundational to debt modeling.
Let's run a highly specific scenario so listeners can follow along. The toy store needs a new delivery van. The total cost of the van on the lot is $38,000.
Okay, $38,000.
I have $5,000 in cash in the bank to put down. The commercial bank is offering an annual interest rate of 5.99%, and I want to finance it over a standard 48-month term. How do I build that model in Excel?
The PMT function requires 3 mandatory arguments. The rate, the number of periods, which Excel calls NPER, and the present value, or PV.
Okay, let's take the rate first. The bank offered 5.99%, so I just typed 5.99%.
No, and this is the most common trap in financial modeling for beginners.
What's the trap?
That 5.99% is the annual percentage rate, the APR. But you are not making one giant payment a year. You are making monthly payments. Therefore, your interest compounds monthly.
Oh,
You must divide the annual rate by 12 inside the formula. So your first argument is actually 5.99% divided by 12.
If I forget to divide by 12, Excel assumes I'm being charged 5.99% interest every single month.
Which is loan shark rates.
Yeah, and my projected monthly payment will completely destroy my cash flow model. Okay, that is a massive detail to remember. Next argument is number of periods, NPER.
This is just the total number of payment cycles over the life of the loan. You stated a 48-month term, so your NPER argument is simply 48.
And finally, the present value, PV. This is the principal amount of the loan. Now, the van costs $38,000, but I put $5,000 down in cash, so I am really only financing $33,000.
Correct. So the complete syntax is equals PMT open parenthesis 5.99% divided by 12, 48, 33,000 close parenthesis.
You hit enter, and Excel calculates your exact monthly cash outflow.
And the strategic value here isn't just getting the number once, it's having a dynamic model to play with.
What do you mean by play with?
Well, if you look at that monthly payment and realize it's just too high for your current cash flow, you don't have to call the bank and ask for new numbers. You just go into your cell, change the 48 to a 60, and instantly see how extending the loan to 5 years reduces your monthly burden. Then you can weigh that lower payment against the total accrued interest over the longer term. It empowers the business owner to model their own cost of capital on the fly.
Exactly. You are using the spreadsheet to simulate business realities before committing actual capital.
It's incredibly powerful.
All right, so we have built an incredible tool here today. We have clean data, logical alerts, dynamic financial models.
We've done a lot.
But a spreadsheet living quietly on your local hard drive doesn't actually move the needle if you can't communicate its findings to stakeholders.
It's just numbers in a void.
Right. We have to format this data for presentation.
Presentation is all about reducing the cognitive load on your audience. When an executive or a potential investor looks at your spreadsheet, they shouldn't have to decipher what the data means. The visual formatting should literally tell them immediately.
Let's talk about color conventions, because there is an unwritten psychological language in corporate reporting.
It is highly standardized. In financial reporting, red fundamentally indicates negative values, losses, deficits, cash outflows. Black represents positive values, profits, surpluses, cash inflows.
Hence, the phrase operating in the black.
That is the literal origin of that phrase, yes.
And what if we are mapping out risk, say a supply chain vulnerability assessment for the toy store?
For risk matrices or operational status, we rely heavily on standard traffic light conventions. Green indicates safety, low risk, or full operational readiness.
Yellow.
Yellow signals intermediate risk, caution, or maybe a developing bottleneck. And red universally means high danger, severe risk, or a critical failure requiring immediate action.
But manually changing the background color of thousands of individual cells based on those rules is impossible. I'm not going to sit there with the paint bucket tool all day.
No, you definitely shouldn't. Which brings us to one of the most visually impactful tools in Excel: conditional formatting.
I love conditional formatting.
It's the best. Conditional formatting automates the presentation layer in the exact same way the IF function automates the logic layer. It dynamically changes the appearance of a cell based on the value currently residing inside it.
Back to the toy store. Let's say I have a column tracking days on shelf for my inventory. I select that column, go to conditional formatting on the ribbon, and establish a simple rule. If the cell value is strictly greater than 365, fill the cell with a bright red background.
Perfect.
Instantly, without reading a single number, my eye is drawn directly to the dead capital sitting in my warehouse. I can immediately generate a discount strategy for those specific items to get them out the door.
You can also use it for demographic targeting, like we mentioned earlier. In your customer database, you could color code the kids' ages column.
Ooh, I like this.
Yeah, so ages 0 to 3 are light blue, 4 to 7 are green, 8 to 12 are orange. When a vendor suddenly offers you a massive discount on a pallet of advanced robotics kits that are only suitable for 10-year-olds, you don't have to run a complex, multi-layered query.
You just look at the colors.
Exactly. You just scroll your formatted sheet, look for the visual density of orange cells, and immediately gauge if your customer base can even support the purchase. You are making the data visceral.
Visceral data. I love that. And to tie the whole workbook together professionally, Tedman and Wilhelm emphasize using the built-in styles and themes.
Themes ensure macro-level consistency. They guarantee that your font choices, your color palettes, and your header styles remain perfectly harmonious across dozens of different sheets.
It looks cohesive.
Right. In a corporate environment, this is how you implement and maintain brand identity in your internal reporting. Crucially, Microsoft designs these default themes with contrast and accessibility in mind, ensuring your data is legible to everyone in the organization, including people with visual impairments.
Which brings us to the final step, the ultimate output. You've modeled the data, you've formatted it beautifully, and the CEO walks in and says, hey, print a copy of the Key 3 analysis for the board meeting in 10 minutes.
The dreaded print request.
And if you don't know what you were doing, you hit print, and the machine just spits out 45 pages of fragmented columns that look like absolute gibberish.
Printing physical copies of digital grids is inherently problematic.
It's the worst.
You absolutely must optimize the output before you send it to the printer. The first line of defense is always utilizing the print preview function, which you can access via Control-P.
Right, look before you leap.
Exactly. This shows you exactly how the data will break across physical paper.
What are the primary tools to prevent that fragmentation, though? because handing a board member a page that just has a list of random numbers with no column headers is just, it's a disaster. It's embarrassing.
It is. The most critical tool for vertical data is print titles. If your data set spans multiple pages vertically, you use print titles to select your top header row, product, revenue, margin, and you force Excel to reprint that specific row at the very top of every single subsequent page.
Oh, so page 2 has the headers again?
Exactly. It maintains the context of the data across physical breaks.
That is essential. Now, what if the issue is horizontal? Like the spreadsheet is just one column too wide for a standard piece of paper.
You have a few options there. First, always try changing your page orientation from standard portrait to landscape.
Give yourself more width.
Right. If it's still slightly too wide, you utilize Excel's scaling features. You can instruct the software to fit all columns on one page. Excel will mathematically scale down the font size and the column widths just enough to force the entire horizontal dataset onto a single sheet of paper, preserving the integrity of the row.
It all comes back to communication, really. A brilliant, logically sound financial model is completely useless if the final physical output is illegible to the person making the decision.
Exactly. At the end of the day, the software is just a tool to facilitate clear, actionable business communication.
Well, we want to give a massive thank you to our listeners, especially the future business leaders at the Dr. Sampak College of Business, for joining this deep dive into the Connect Master MIS module on Excel fundamentals.
It's been a great review.
It really has. Whether you are managing a local toy store, analyzing global supply chains, or projecting corporate debt, mastering these tools, the data sanitization, the advanced logic, the dynamic formatting, it provides a concrete competitive advantage in literally any field.
It truly is the difference between being overwhelmed by the sheer volume of data and being actively empowered to extract real value from it.
Absolutely. And hey, we'd love it if you could take a second to like, subscribe, follow, and share this episode. And we specifically want to invite you to leave a comment to answer today's discussion question.
Right. So here is the scenario we want you to consider for the comments. Think about a business you know really well, or even just your own personal financial budgeting. How could you specifically deploy Excel's conditional formatting tool to instantly expose a hidden problem or maybe a new opportunity within that data?
Get creative with it.
Yeah, walk us through your specific rule set in the comments. We'd love to read them.
Next time, we're taking everything we just built today and we are kicking it into overdrive. Get ready to pivot from basic modeling into aggressive strategic extraction in Module 24, Introduction to Data Analysis with Excel.
That's where the real magic happens.
Oh yeah. We are going to look at how to truly interrogate a dataset. You definitely won't want to miss it. We'll see you next time.